Okay, so the topic we're covering is exponential functions, and that is a mathematical function in the form of f of x equals a raised to the power of x, where x would be the variable and a is a constant or the base of the function. So the most common base that's used is e, which is also equal to 2.71821. And using e, you would take f of x equals a to the power of x and change that to f of x equals e raised to the power of x. When the exponent in the function increases by 1, the value of the function increases by a factor of e. So when the exponent decreases by 1, the value of the function decreases by the exact same factor. So in other words, it's divided by e. So here's an example. When exponents increase by 1, the value of the base 10 function increases by a factor of 10. And when the exponent decreases by 1, the value becomes 1/10 as great. So using that, the example I chose was base 10, obviously, and x equals 3. So for this example, you would take log times 10 raised to the power of x and equal that to log times 10 raised to the power of 3, and you're substituting 3 in for x. And you're equaling this to log 1,000, and that also equals 3. So continuing that, if you were to change the x equals 1,000 and keep base equals 10, you would take 10 times log raised to the x power, which also equals 10 times log of 1,000. Again, you're substituting in what you have for x, and equals 10 cubed, which we had originally in the other problem, and you're equaling that to 1,000, which you were looking for in the first place. So the second step to exponential functions is the graphing portion. As we have on the left, exponential growth versus decay. Exponential growth is when the graph is going up, and an example of this is y equals 2 times x plus 3, and obviously the graph is going up, and for decay, the graph is going down, and the example I chose was y equals 5 minus x, but the negative x is raised. So for writing exponential functions, that is the next portion. I have two examples. So for each set of characteristics, write an equation of a possible exponential function or functions. So for the first one, you have the y-intercept of 3, and it's decreasing, it's not increasing. So you would take what you have given to you in number 1 and write y equals 3 times 1/2 raised to the x power. Remember that the exponential function is f of x equals a raised to the x power. And when you have 3, that is the y-intercept, and that's also given to you by the a value. They're in the same spot. B, which is 1/2, tells you whether the function is increasing, which is b is larger than 1, or decreasing. And b is substituted in right there again. And that was the decreasing problem. And the increasing problem would be you're taking y-intercept of 1, which is also increasing, and using 3 from the earlier example for b. So with that information, you would take the 1 and put that in the spot for a, and then the 3 would be in the spot for b, and it's going to be raised to the x. I didn't write it, but it would be raised to x. And that just about covers exponential functions.